Hey, welcome back everyone. This is Sean from HFR. We're picking back up on this Denon receiver. And in this video, we're going to take all those components that we purchased and mentioned from the previous video that we needed to procure, and we're going to get them into the receiver and start testing them out. And we're going to discover if they work or not. A bit of spoiler there, especially if you've already seen the real or the short video I made several weeks ago. There's going to be another issue. That being said, let's go ahead and get into it. Well, components are in. I've got all the capacitors I need to recap the board, minus some of these I'm not going to touch, i.e. these big two right here. I don't think they're an issue whatsoever, because the issue isn't really on the power side. Well, it could be with the lower voltage being developed by these diodes, but it's not on this side over here. I suspect it primarily to be on the audio side, audio, and then whatever regulated voltage is used for these relays, although we only have one bad relay. So, and again, what's drawn me to that suspicion is what we're seeing on the board itself that I discussed earlier. But I'm going to recap as best as possible with the components I bought, and most likely, we could probably look at one or two of them afterwards to see if they actually are measuring bad. When it's in circuit, you have to deal with either series capacitance or parallel capacitance rules. And so the actual value on the capacitor might not be what you're measuring, but that's just simply because it's in circuit. So, testing afterwards could produce something for us to share. But luckily enough, actually, the relays that I put on order, both the light for light, same part number, came in the same day as the what I think would be a suitable sub, came in on the same day. These came in from actually Georgia, even though they were on back order for some time. 2 were ready to ship, 4 others had to be put on back order. But by the time these got sent out, this had already been sent. It was coming from North Dakota, I want to say, from the DigiKey facility up there, or probably warehouse. They actually both arrived on the same day. Let me get them out of the package for a second. Okay, so I got them stacked on top of each other just so you can see the physical size difference between the two. Of course, the main one, this one right here, left hand, and the one I think would be a good sub for it, right hand. So you can see that we're about 5 millimeters longer in length. You can see that the height of them are different too. Of course, we looked at the data sheets and we knew this beforehand. You turn it over. If we stack them this way, well, you see how the pins align right here perfectly well enough. But these pins over here would have to be brought in 5 millimeters. So when we go to replace this, I'm going to replace it with this one, and we're going to see how it performs. I'll probably record that section, what I'll do to try to get this in there. But I'm not going to record all the recapping of these capacitors and stuff. This video is already long enough as it is, if I'm being honest. And so most of my videos, I'm lucky to get, say, 6 to 10 minutes of viewership, if that at all. These longer videos, of course, I assume that there are some people who watch them to gain some stuff out of them, but I do these longer videos not for just my sake, and explore down things that I'm curious about, which is why I'm doing this regardless. I'm curious to see the performance long term. But because these videos hopefully tend to serve as a maybe a training aid or of use to somebody else further down the line, who's willing to sit through and look at the chapters and actually watch the content. But anyways, I'm going to cut out. I'm not going to record the replacement of the capacitor portion, but when we come to working on this relay, I'll come back and we'll start recording again. I now have our relay removed from the PCB. Okay, here goes the suspected bad one. Here goes the like-for-like replacement. Here goes what I think would be a suitable sub. And we're going to do a performance test on this. What I'm going to do is take my negative lead from my bench power supply over here and connect it up. Okay. Then I'm going to check for continuity between these two posts here. Alright, now I'm going to slowly increase the voltage from my power supply and we should get an audible click. And we do right about 7.3 volts. I'll hold this closer to the microphone so y'all can hear it if it didn't come through. Okay. And now I'm going to check to see if we have that continuity between these pins. And we do. And we do. So about 7.3, it is capable of clicking over. And let's see when it releases. About 1.6 volts. Okay, does our replacement have that same standard? Well, I'm at 1.6 and hasn't turned on. Hasn't turned on at 7.6, but it did right around 8 volts. We got that click. Alright, let's see when it cuts out. About 2.4. So a little bit of a higher voltage. It cuts off. That was me, that wasn't it. Okay, now let's check it with this replace suitable sub. I'll turn this, or hopefully suitable sub. Turn that voltage all the way down. Alright, let's start increasing it. Alright, we get a click around 7.3. And when does it release? Sounded like it was around 4. Yeah, around 4 volts it drops out. So it definitely drops out a lot sooner than the other two when the voltage comes down. Which I suspect it would, given the coil's a higher resistance, so you're not generating as strong an electromagnetic field, I would presume. Or you would need a stronger voltage to produce a stronger electromagnetic field in order for the relays to click over. Now, here's a caveat. This is testing, for all intents and purposes, good on the bench, right? But I know from working on relays that what tests good on a bench when you don't have in-circuit resistance and other things to deal with doesn't necessarily mean that the relay is going to behave good in circuit. Alright, so I suspect this to be bad, but it's potentially, it may not be bad. Okay, and here's the reason why I'm thinking that as well. Give me 1 second. What can cause something like that? Well, again, capacitors can cause a voltage to drop, not be sufficient enough and can have an effect on the relay. Additionally, all the capacitors that we're measuring weird in circuit Well, the majority of them, when I took out a circuit, were measuring with my volt ohm meter, just measuring capacitance as well as measuring resistance across the capacitor. Primarily, the bulk of them seem to be about in tolerance as they should, with the exception of this one right here. This one was way off. This was a 16 volt, 1000 microfarad. I think I replaced that one. Where did that one get replaced at? Somewhere on here. 16 volt, 1000 microfarad. Yeah, right here. That's one I replaced. And that's dealing with this lower voltage regulator section. So it's a potential that whatever voltage was being produced by these diodes here, lower DC voltage, it's a potential that was having an effect on this relay. It's also still a potential that these either voltage regulators or transistors that are sitting here, they're marked with Q's, so I assume transistor right off the get-go, but I could be wrong. That could be having an effect on the relay as well. But again, I won't know until we get a relay in and get it back into the chassis and start probing things out from there. Okay, now as for settling my curiosity, you see this sub will work for this. As I mentioned, these legs are 5 millimeters too far backwards. So what I'm going to do is I am going to fold these legs in this direction, and then I'm going to solder to them posts that I make myself. And then I'm going to cover up those legs with a conformal coating so they don't potentially touch this resistor we have here and short out. The voltage comes to here. I'd hate for that same voltage to come across this resistor here and cause problems. But once I get that done, I'll come back and show you what it looks like. Okay, and here it goes. You can see the posts are lined up. I have to trim them down a little bit, but then some conformal coating put on the back end here. You can see all that. And just kind of put it into the board, and it fits pretty good. So it's just going to be soldering it in, and we'll solder it in, get most of this back together into the amplifier, and then we'll see how it functions to see if we've got our center channel back. And if not, we're going to have to do obviously more troubleshooting. It is precariously kind of put back together with as minimum screws as possible and everything. Got an audio tone going through here from my cell phone, and we can let me turn my filters off. This little test speaker here, and just go across each terminal, see if we're getting a 1 kHz tone. That's front right, front left. Still nothing on center. Okay, as I suspect, after testing that old relay and everything, it's potential we got a different issue. Hopefully voltage to the relay, because that's going to make it troubleshooting wise. Hopefully it has nothing to do with that volume control over here on this side board. I would think if the audio is not coming through, then the output of that IC is going to be low because the audio is being grounded out somewhere. And again, we know audio is coming from here to down there. So yeah, hopefully it's not this sideboard. But I wonder if I can take these analog daughter boards out and still have access to everything on the inside, and work from there with my oscilloscope. We'll try that out. We're going to start probing again, since we still don't have audio out of our center channel. I'm going to come take a look at this volume adjust again. Coming to the sideboard over here. And pins go, what is that? Front left to surround left to center channel. This pin 1 is front left. Again, if I increase the volume knob on the front of the chassis, extremely low level audio, but we can see it increases. Okay, so I'm going to keep it right there at like 4-ish volts. Front left, and we have an analog ground. Surround left, 3.5. Alright, so pin 5, 1, 2, 3, 4, 5 should be center. Oh, we get 2.6. So we're actually getting something now. I think last time it was acting flaky. And here goes the rest of our channels. 3.5. There you go. 4 volts. Over 4 volts, we're getting into the Helios speakers or whatever they are. I just kind of want to go in and check that relay to see if it's getting the voltage that's required in order to operate. Okay, so I've got my multimeter. I'll try and stick it into here a bit. That should work, hopefully. And I know there are small resistors, and I know it's hard for y'all to see from the perspective of where I'm at, but there are resistors that are close to the coil. We should be getting a voltage that they actually attach. Terminated, one side of that resistor is terminated to the coil where the positive voltage comes in. So you see here on this very first coil, we're getting about 8 volts, right? So I should be seeing 8 volts. Now the second resistor is actually hidden underneath our suitable sub. Remember, it's longer, but there we go, 8 volts. And then this one sits right here, and 8 volts. So we're at least getting that. That coil is, barring ground, the ground for it should be energized. Okay, I've turned the filters off, so sorry this section's a bit loud. But I devised a simple test. I don't have audio going through it right now. You can see kind of this clip lead over here. Going to the chassis, the other part right here. Okay, and I've essentially taken this to the ground part of that relay underneath the board, right, to see if the issues with the ground. Okay, now I don't have any audio going through because I don't want any voltage present at these terminals here for doing a continuity test, but you can see as of right now it's completely open. I take my multimeter across these other legs that I've soldered onto those terminate posts for the relay. Okay, I'll throw a picture up in the comments. So this will be the input to the output, going directly to here. Of course, going through that little capacitor for filtering. But when I connect this, let's see what happens. Okay, so I hear the relay physically clicking over now, and if I check from here to here, we have continuity. Now the question is it because the ground is not being present well enough, which most likely that answer is yes, or is it because this relay isn't the right type? So I don't think it's the relay, but what I'll end up doing, I think it's the ground. I think it's something to do with the transistors that we were seeing earlier, because those were all tied to an appropriate ground, tying all the ground points together. So I might have misspoke and said those were going to the positive posts. I've since learned that no, all those tied to the side that should be grounded. So I decided to put in an audio board back in and just hook my SIG-gen up to it so we can roll out the relay definitively, and I think we have. There you go. You hear that 1 kHz tone coming through. Perfectly fine. Tell me that it's on the ground side of that relay. So that's where our focus is going to be next. Got the board back out of the chassis for this Denon receiver, and given that we tested that the issues most likely on the ground side of that relay, put my big finger in the way. But I went ahead and marked the board right here where I'd soldered that wire to it. And if we follow this pad down, all the way down here, and it's going to come over this way. We follow these traces up, and we just keep following. Here's where they join back up at. But anyways, I'm just going to skip, come straight to what I want to show you, and focus in. We have a series of transistors sitting right here, and then this is the pad in which that relay connects to. Okay, so it's coming to this pad on this transistor. Now the assumption transistor, we got 3 pins. Okay, unless it's a form of voltage detection or anything, or something like that, but my best guess is a transistor. NE is going to be type code, C3 day code. This is kind of obscure type code. We'll see what we can find out. But if I was to take my multimeter across from here to the relay, we would definitely get an audible tone. Hold on 1 second. Turn on my filter so you can hear that tone with me. Okay. And then go onto that pad. There you go. All right. In addition to that, you see this this trace that's running underneath all of these? Well, that's connecting all the left pads together. So say this one right here, and this one over here, same with here. So we know that this is going to be the ground side, and all these go to a relay where audio is coming out, and then all the left pads are connected together, heading up, and then coming up this trace right here to this pad and heading out to several components. Okay, now specifically with each of these transistors, they have their own input, essentially coming all the way up to this connector here, with the one that is going directly to the relay that we're concerned with being this pin right here. Okay, so I'm taking a step back and looking at this, trying to think through the issue. Okay, oh, with the exception of these 2 transistors, we can see that voltage is coming in from that pin, but it's actually feeding to both of these transistors, and not just this one. And you know, we can check from pad to pin, and we're getting obvious continuity. So it's not going to be an issue with the trace. Okay. So what is this telling me? All right. Well, this is either collector or emitter. That's probably collector emitter, since this might be the collector side, that might be the emitter side, or vice versa. But anyways, this is going to be the path in which current is going to flow, okay, out of each one of these transistors, essentially here through there, there through there, there through, you know, this pin, but obviously that's flowing up this way. So this right here is going to be what will bias the transistor, the right pin. So most likely this is going to be an NPN transistor. So we're looking for a voltage here in order for this transistor to bias, to allow a path for, you know, current to flow, in which case the relay is going to kick on. What this is also telling me is I don't believe the issue is on this pin here, or this one, or this one. I mean, mainly, like I said, because we get continuity, so I don't think it's any of the components. If I can, probably should have put on different probes. I don't think it's any components coming up this way going other out, because we would have a similar issue with every single transistor. I also don't think it's the voltage coming from this pin up here at the connector being bad. Otherwise we'd probably have an issue with both of these transistors, so we would essentially lose our center channel, and then whatever, I think this one controls left channel, I don't remember, I pinned it out earlier, but we would have two channels that were out instead of just one. So I'm primarily thinking that the issue is with just one of these transistors. However, because they're tied in circuit, they seem good. Well, these two have a lower reading in circuit than the rest of them. For instance, let's just put positive on the base, and we'll go to this first one over here. Alright, you can see we get 1.5, and then base to collector or emitter 1.5, right? If we go between the two, we're getting 0.5 steadily climbing, okay? However, when I check this one, we're a bit lower, 1.2, kind of climbing, 1.2 and kind of climbing, 1.2 and 1.2. When I go between here, what are we looking at? 0.7, 0.5. But you know, I go beyond these two, we're back to 1.5, 1.5. So obviously these are lower, and I don't know if it's because it's in circuit or because one of these is bad. So I need to take them out to actually check them. All right, testing time. Got my multimeter set to diode mode. So you're all oriented. This pin right here should be the base for each one. And then we have what? One's base, 2 is going to be emitter, and 3 will be collector. So that's base, that's emitter, and then the back side is collector. So with right probe on base, because I suspect this to be a NPN, we can go between base and emitter over here. And We are getting 1.5. So that's good. Base to collector. And this right one is my suspected good one. The left one goes to the center channel. 1.5 voltage drop, we're good. All right, now let's check here. Base to emitter. And we're getting nothing at all. Okay, how about base to collector? Well, that works. What are we getting collector to emitter? Positive we might not get anything, but it should at least not be a short, I believe. I'm not getting anything. Let me check this side, just as a comparison. So this is looking like we have a failed junction between base to emitter on this transistor. So that looks like it's our cause right there. Okay, so I'll walk you through my research. Found this website, fixpart.com, okay, and or .co.uk. But anyways, they had a nice listing of our receiver's components in here, specifically showing the NE coded, type coded transistors. Where I was able to find them. Again, the right side is going to be date code, so I'm not really too concerned about that. And the way we can tell is, well, look, the part number for this one is KRC105S. Okay, we see it there. Still NE KC105S. Still the same overall part number. So what I did is I went ahead and pulled up a data sheet on that guy, which we have over here. And it looks like our measurements, measurement A, yeah, 2.9. I care about measurement G. You know, I'm just verifying a couple of measurements, 1.9. E, what was that? 2.4. So the part looks like it's going to fit well. Okay. When we look at 205S right here, we can actually see that this package includes resistors that are built into there, which obviously with the testing I'm doing, I'm not putting a resistor in line to our base or, you know, over here at our common or collector, or excuse me, emitter. Yeah, that's the part that the arrow's on. That's our emitter. So those resistors are absent with the testing I'm doing. But at least that tells us, you know, this is most likely going to be the part. Input voltage 12 to negative 105 volts. So there you go. That's probably what's causing it to trip negative voltage or something, but either way, or those resistors not being in with our testing. But this is starting to make more sense now. The ratings and stuff with our very basic measurements, and so I believe this is going to be the part that we need. Second to that, well, where do we get the part? I can't find it on Mauser. I did come across this, and you can get it off of LCSE. You can get what stock? They got 8900 in stock. We're looking at 20 at 2 cents a pop. It's crazy. So whatever that is times 20. Of course, the price per item falls down the more you order. But wind source, ultramil, Mountain View. Some you have to order. .co. over there in Europe. But yeah, we'll probably purchase from LCSC whenever they come in. 50 volt, 200 watt, 100 milliamp, NPN slot, 23 bipolar transistor. So it is a BJT. We'll try this one out, and maybe this will get our system back working. Scratch that, because you gotta buy bulk if you're buying online. A bit. I did find a suitable sub here. The DDT-C123JCS-7S. Anyways, here's the data sheet, and there we go. As long as we get this one right here, 123 JCA at 2.2 and 47. Then it should be good. Should be the same thing we're looking for. Okay, well, our subcomponents have come in, and this one actually being directly a like for like in every way. Part number again right here. I'll put up in the camera so that way if y'all want to take a snapshot of that part number, you can get it yourself. Again, from Mauser. And so we'll take off this transistor here. We'll put the new transistor in and test it out, and if it functions as it should function, then we'll take back out what the this relay here, and we'll put in the sub relay and see if it will maintain serviceability. Again, going to be a bit tricky. You'll have to do most of this replacement underneath the microscope, because you can see just comparatively how big it is to my thumb there. It's a very small component. And when I was attempting to see if we can get it to work with just a transistor, I messed up some pads, so I'll need to fix that as well. So let me get this underneath the microscope and we'll begin that series of work. Okay, well, we've got a bit of trace repair accomplished and that transistor put in, and in circuit is measuring how I believe it should. So we also put some conformal coating on the top of it just to protect the traces, because they have came up from the board. So our repair needs to be adhered without the ability of, say, if I was to push on the transistor itself, ripping the pads even more. So at this point, I'm going to get it back into the amplifier, and we're we're going to test it out. Okay, and here we go with attempt number 30 billion at this point. And nothing's blown up. Let's turn it on. Stay on, stay on, stay on, stay on, stay on. We staying on? Yes. Yes, we are staying on. All right, let me get a 1K hertz tone put up into this and see if we got our center channel back. Okay, and here we go. I can get this off the magnet. Come on now. That's front right. Front left. And do we have center channel? Yes, 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 yes. Okay, okay. I gotta. This is a recording, so I feel like I need to run to like somebody in my house and share with them my my genius. But anyways, I'm so excited about that. That's awesome. So what this means is I will swap out that relay for the hypothetical suitable sub and see if it still functions, and if so, I'm going to tidy up all the other PCBs, address a lot of the soldering issues, the legs being too far, not trimmed enough coming out of the boards, and I'll get this button back up, and we will do a final test with this in my as part of my entertainment system in my living room with HDMI coming through it. And with the hypothetical suitable sub in, we're still getting nice 1K hertz tone out, so it seems to be working pretty well. Time will tell, but we were able to prove that we can sub out some components with a different part number for that transistor, and then a slightly different form factor but with modification for this relay, and it still worked. Trying to get and we're looking about on the higher end of that 12 volt DC higher end of the 12 volts DC needed to go across the coil to activate the relay, so just slightly higher than the other ones, but not by much. Still inside quote unquote 12 volt range, I guess. This one over here is 13, so I think we're going to be okay there. Time will tell though. So like I said, I'm gonna get this all buttoned up and get it put into my entertainment console and see how it performs elsewhere, video and stuff. Okay, so it's currently updating, but my subwoofer, because I don't have an RCA cable, and I'll have to do that later. I did run through a setup, and HDMI is working, the audio channels are working, Wi-Fi is working, and obviously Bluetooth is working. So, and I'm just waiting for this update to finish, and we'll close out the video. Pro tip: if you don't have the calibration microphone for the system, a lapel mic with an extremely long lead, you're looking at 3 pins, 1, 2, 3, will work just as well, although audiophiles might disagree with that. But yeah, this will help. This was allow me to perfectly calibrate the AV receiver. And obviously I don't have a boom stand, so I just used my my vacuum cleaner as a mic stand. And there we go. I can already tell you, miles ahead of my previous AV receiver system, just the atmospheric sound in here, regardless of needing to go through the calibration again once I get my subwoofer hooked up. Yeah, and ARC works as well. TV off, or receiver turns off, and if I turn it back on, it'll turn back on. So I guess the best way for me to finish out this video is just to say, well, thank you for watching. Hopefully this repair video is educational for you, as it was for me learning my way around this Denon receiver. I'm very happy with this purchase and the repair. If you have a home theater system in need of repair, my business description is down in the doobly-doo. If you want to reach out to me, we can work something out from there. But that being said, if you're new to the channel, please consider liking and subscribing. If you're returning, please consider giving this video a nice thumbs up. Leave me some comments down in the doobly-doo as to what you think as far as this repair went. But all that being said, thank you for watching. Take care and goodbye.
Bark?